Hello and welcome to another video. Today we're going to be looking at some circles and how the curves of these circles can relate to some of the angles inside of them. So first I'm going to do a quick review problem that it's not really a review problem, but it establishes the principle of what we're going to be doing today. So I'm going to take my compass. I've set that too big. Like this. I don't need it to be huge. And I'm going to draw a circle. Okay. Now, we're going to measure the point. We're going to take the point at the center of the circle, call it point O. That's usually what you do with center of circle points. And we are going to put 2 points on the circle. We're going to do point A and point B. And then we're going to draw a line through point B and point O, the center. And where that touches the other side of the circle, that is point C. We're also going to draw lines between OA and BA, like that. I'm going to number some of these angles. This is angle 1, this is angle 2, this is angle 3, and this is angle 4. Now what can we prove by looking at this? Well, firstly, since O is the center of the circle, this triangle right here is isosceles, which means that angle 1 and angle 3 are equal to each other. What this also means, because this is a triangle, just because it's a triangle, not just because it's isosceles, that angle 1 plus angle 3 plus angle 4 is equal to angle 4 plus angle 2, because angle 4 and angle 2 are on the same line, forming 180 degrees, but so is this triangle, since all angles of a triangle add up to 180 degrees. So now, what we can show is if we take out the angle 4s, that angle 1 plus angle 3 equals angle 2. And because this triangle is isosceles, angle 1 equals angle 3, so we can rewrite this as 2 angle 1s. Angle 1 plus angle 1 is angle 2, and therefore angle 1 is 1/2 of angle 2. And this is an extension of a theorem which states that these two angles in a setup like this, like no matter how this is set up, even if this isn't isosceles, these two equal this. This is just an extension of it where this triangle is isosceles, that we can prove something like this. Now what this means, however, is that angle ABC, or angle 1, but I'm just going to put angle 1, is equal to 1/2 of this arc right here, arc AC. This right here. I'm going to put little dotted line, like little dots along. This arc right here. Angle 1, this right here, is half of this arc. Now, we can extend this. And what we're going to do is we're going to draw a slightly bigger circle, because it always helps to have a bigger circle. So, like that. Okay, let me fix my papers. There we go. And we're going to extend this a bit. We're going to keep the center of the circle named point O. We're going to put a point A up here, point B here, and a point D down here. That looks like a P. It's going to be a D. And then do the same thing again, and we're going to draw in between these. So we're going to draw a line between BA, like that. We're going to draw a line between B and D. And then we're going to draw a line between B and O. And label this point C. Now what we can do is we can already extend what we know. So what we want to show is that angle ABD, this entire angle here, is half of this arc. So how we can do that is by this reasoning up here, we can essentially draw lines. I'm just going to use dashes here, not lines. But you'll see that if we draw between OA and OD, we have two cases of what we just saw. Up here, like the same thing here, we have OBCO and we have CBDO. So now because of this, we know that angle ABC is 1/2 of arc AC, and we know that angle CBD is 1/2 of arc CD. And now if we add these two, we know that ABD, angle ABD, is just 1/2 of arc AD. Simple as that. Now, we're going to extend this just a little bit more, and I'll do another extension or another case like this in next week's video, So what we're going to do is we're going to draw another circle. Stop turning. Boop. Circle drawn. And now, mark point O as the center. And now we're going to put another 3 points on where BC isn't the middle line. So what we're going to do is we're going to have point B here, point A here, and point D here. And then, as always, we're going to draw a line through BO to point C. And then we're going to sketch out the rest of these lines like so. Now, what does this mean?
Sorry, I didn't catch that.
Well,
what would you like me to define?
Now, instead of adding the two, let's say we want to find ABD. Now, if we want to find that ABD is 1/2 of arc AD, we can already show that ABC is 1/2 of arc AC, and that DBC is 1/2 of arc DC. We subtract the two this time, and we get that angle ABD is 1/2 of AD. Bye, guys.